Hi, I'm Ms. Fung. Today we're going to continue with exponentials and logarithms, and we're going to look at sketching the exponential graph. We're going to look at y equals a to the x, and we're going to try to sketch it for when a is greater than 1 and in a different scenario when a is between 0 and 1. You'll see why these two scenarios very shortly. So for y is a to the x, where a is greater than 1, let's try and do, let's plot a table for 2 to the x. So where a is equal to 2 and 2 is greater than 1, right? So when x is negative 3, 2 to the negative 3 would give me 1 over 2 to the 3, which is 1 over 8. 2 to the negative 2 would be 1 over 2 squared, which is a quarter. 2 to the negative 1 would be 1 over 2. 2 to the 0 is 1. 2 to the 1 is 2 to the 2 is 4. And 2 to the 3 is 8. So let's sketch this. So we see that as we go past 0, 2, 4, 8, 16, it becomes big really quick. So this is what we describe as exponential graph or exponential growth. It's going really fast, much faster than a linear graph. See, it goes up really quick. And as we go to the negative side, so less than 0, we can see that it shrinks really fast and it almost becomes 0 but never quite touches 0. It goes a half, so 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over 64, 1 over 128, 1 over a lot, but never 0, so almost 0. And because it never touches 0, this line here is called the asymptote. So we can describe this as x approaches negative infinity, then our y value gets really close to 0 from the positive side. So the asymptote is here, and the equation is y equals 0. Remember, whenever you sketch graphs, you always have to give the equation of the asymptote. And we have a special point here. The y-intercept is at 0, 1. And we know that the range, so the range of the graph, so the y values, is between just over 0 to infinity, or in other words, r plus, not included. So r plus doesn't include 0. We also put a second point just so that we can see what the graph looks like. Here we have 1 and 2. When x is 1, y is 2. Let's do another graph. So we've done 2x. Let's try another one. Let's try 10x. What would that look like? So 10 to the negative 3 is the same as 1 over 10 cubed, which is 1 over 1,000. 10 to the negative 2 would be 1 over 10 squared, which is 1 over 100. 10 to the negative 1 is 1 over 10. 10 to the 0 is 1. 10 to the 1 is 10. 10 squared is 100. And then 10 to the power 3 is 1,000. So this graph will look like this. It shoots up even faster than this black dot is 2x. This red line is 10 to the x. So you can see that 10 to the x means it's going up a lot faster. We still have the asymptote. We still are approaching 0 from the positive side as x is approaching to negative infinity. And the y-intercept is still the same, but now up. So how do we make it look different when we're sketching? The point 1 is now 110, not 1, 2. What about when we have a is between 0 and 1? What would it look like? So here we have a half x. Let's explore that. So when x is negative 3, we will have 2 cubed, or 8. When x is negative 2, we will have 2 squared. So we have to bring it to the top to make the power positive. When x is negative 1, it will be just 2. When x is 0, obviously that's 1. When x is 1, that's a half. When x is 2, a half squared is a quarter. When x is 3, then 1 over 8. So we can see that it's like the reverse or the reflection of the other graph. The dotted line is 2x again. Our new graph, a half x, is the red line. And we can see that it's a mirror image along the y-axis. So as x approaches positive infinity, now we're approaching 0. The asymptote is still the same. the y-intercept is still the same, and the range is still the same. But the point 1 is now 1, 0.5, 1, 0.5, or 1.5. So we can see that this is a reflection in the y-axis. So between 0 to 1, when a is between 0 to 1, we have a fraction. And another way to write 1 over 2 is to write 2 to the negative 1. So that is the equation we just did just now. Let me bring it up. So that equation can be written as that. You should be familiar with that from the previous video and exercise. And let's compare it to 2 to the x. What's the difference between these two? Then we can see that this is a reflection of that. Or in other words, if we call this g of x and this f of x, then g of x is the same as f of negative x. Because if we put negative into x here, we get the same equation. So that is definitely a reflection in the y-axis of 2 of x. Let's do some translations. So if we add 3, we've done this a lot before with other graph, what happens to our 2 of x? Well, 2x plus 3 would look like so. And so now it's translated through units in the positive directions of the y-axis. And where is our y-intercept? Instead of 1, we're adding 3. So our y-intercept is now 0, 4. And where is our asymptote? Instead of y equals 0, we're going to add 3. So now it's y equals 3. Now, you can add in the point 1, 2. Instead of 1, 2, it's going to be 1 and 2 plus 3 is 5. What about if we multiply our 2 of x by 3? So having a constant in front of it. So multiplying each value would mean making the y value bigger for each of them. So our 2 of x is here, our 3 times 2 of x is there, and we call this a dilation by a factor of 3 from the x-axis. Again, our y-intercept has changed. Instead of 1, multiply that by 3 gives us 0, 3. So in the previous example, the y-intercept, we added 3, so that's why it's 4. But in this example, we're multiplying by 3, that's why it's 0, 3. Very careful. And the easiest way to do it is just plug in x is 0, 2 to 0 is 1, 1 times 3 is 3. And the asymptote is still the same. Now what about if we have minus a to the x? What would that look like? So let's do minus 2 of x. Minus 2 of x looks like that. This time it's a reflection in the x-axis. So now the reflection means that the y-intercept is no longer at 0, 1. It is now at 0, negative 1. And the asymptote is still the same. Example 7. Here we have negative 2 to the 3x. What does the 3x do to the negative 2? So here we have the original 2x. So the negative 2x would have looked like that. But the 3 makes it look like it moves a lot faster. It curves a lot more. So again, that 3 means a dilation of a third from the y-axis. And see, remember when we put a number in front of x, the dilation is described from the y. Okay, and the negative is a reflection in the x-axis. See, it's reflected in the x-axis. The x-axis is like our mirror. And the y-intercept is still at 0, negative 1, like the negative 2x. And our asymptote is still at 0. Now be very careful when you're sketching. I know the program I'm using makes it look like it's touching, but it's not touching. Make sure that it doesn't touch the asymptote. Never touch the asymptote. Example 8. So here we have negative 2 to the 3x, like we've seen before, plus 4. What would that look like? So it looks like the graph before, but now we're moving the whole thing up by 4. So that's 2x. Minus 2x means it's going to look like it's down here. And minus 2x to the 3 means it curves even faster. And then moving it all up by 4 would look like this red line over here. So now it's a dilation of a third from the y-axis, a reflection in the x-axis, and a translation 4 in the positive direction of the y-axis, or 4 up. So the y-intercept is over there. Just check. When x is 0, 3 times 0 is 0. 2 to the 0 is 1. Minus 1 plus 4 is 3. So that's good, 0, 3. And we can see the asymptote has been moved up by 4. Let's recap what we have done and compare them. So 2 to the x plus 3 looks like a shift up, but 3 times 2 to the x looks like something moving faster up. So now you can look at these two graphs and see what the 3 does in those two circumstances. That's a dilation, and that is a translation. Here we have negative 2x. So here we have the negative means a reflection in the x-axis, and the 3 would look like that. Sorry, the negative 2 to the 3x will look like that, but now it moves faster, it curves a lot more. And negative 2 to 3x plus 4 will look like that, but shifted up by 4. Let's compare these two, negative 2x and 2 to the negative x. What does they look like side by side? Well, negative 2x is a reflection in the x-axis, and negative x the negative in front of the little x will be the reflection in the y-axis. That's it from me today. Have a go at reviewing this video and seeing if you can describe what we have described, and see if you can visualize the line and predict what it should look like. You can also use your CAS to sketch this and practice using your CAS to check your answers. Okay, thanks for watching. I'll see you next time. Bye.